Hello, everyone. Welcome to the lecture for today. Today, we're going to be going over parameter passing and then arrays, which are two really important concepts to get across in computer science, especially parameter passing. It's something that's going to come up a lot, especially on midterms and finals. Today, we're going to be talking about one of the easier method of parameter passing, which is called pass by value. This is going to be separate from another concept that we'll talk about later called pass by reference, where things get a little bit more confusing. But today we're just going to be talking about pass by value. So when you call a method, so the static methods that we've been talking about are a good example of this, where you can call them from anywhere within the code and then they compute or they do something and then return a value back to the user. How are the arguments, which are the values that you actually pass into the static method call? So think math.square root, you pass in a value, say 4.0 or 8 or 16. That's known as the argument of the square root method. So that is what's passed into the function and treated as the formal parameter. The formal parameter is what you define during the method header of the static method or the instance method later on in the class, and defines a value that must be passed into the method in order for the method to function properly. The second question we're going to be talking about today is when the called method body returns, how are the results from the piece of code or the block of code that you've run communicated back to the code that called the method? So those are the two questions we're going to be asking today in regards to parameter passing. So as an example, the example method that we're going to be using today is a method called GCD that computes and returns the greatest common divisor of two integers. So if you pass in down here 24 and 80, the greatest value or the highest value that divides into both 24 and 80 is the integer 8. And the greatest common divisor that divides into both 24 and 24 is 24. So the method signature, let's break it down a little bit further. We have public, which means that it can be called from any other class. So it's not confined to just whatever class that we're writing the static method in. We have static, which means it can be called from a static context. It does not need an instance of an object to be called on. We have an integer, which means that at some point during this private or this public static method, we are going to have to return an integer back to the user. We have the name, which is GCD, which just stands for greatest common divisor. And then we have two integers, int I and int j. These are the formal parameters. When we call the GCD method, so an example call might be something like this. These two numbers that we're passing in, 24 and 80, are the arguments to the GCD method. So let's say that we have this private static int greatest common denominator, greatest common divisor method. We set k equal to 1. This is a local variable, so we cannot use this variable outside the scope of this method. And the scope of this method is just anything that's contained within the curly braces. So let's say that a very simple implementation of the greatest common divisor method is that it just returns 1, because 1 is a divisor to any integer. So this is technically a correct code, although it's not the greatest common divisor. This would just be a common divisor. Then let's say that we create integers a and b, and then we set integer c equal to the result of the greatest common divisor between a and b. How does the call work? We hinted at this a little bit last week when we talked about the thread of execution. That was that graph that I drew up on the board where we start, Java goes and it says, hey, where's my main method? And it starts running like that. And then anytime you call a static method, the thread of execution switches to that static method for the duration of that static method. And then it switches back to main after it's done. So there's going to be an example here. This is the method GCD that is being called. I and j are its formal parameters, as it's called. The things that must be passed into the GCD in order for the function to run. So this is a fragment of the calling program. So you can think that this potentially would be in the main method. This could also be in another method as well, because you can call functions from other functions. In any sense of the word, A and B are the arguments to this call of the greatest common denominator method. Greatest common divisor. Okay, suppose the solid red arrow indicates where the program flow of control has taken us so far. So you can think that this is basically right after public static void main, code that is just running in Java. So first thing we do is we define two variables a and b as integers right there. And since they're not initialized yet, we put question marks in these boxes. But essentially we're telling Java, hey, we want to make two integers a and b, hold space for them down here or in your memory locations. Then let's say somehow later in the code, a gets set equal to 24 and b gets set equal to 80. So we could just say like a equals 24, b equals 80. Either way works. Then we call int c equals GCD a and b. Now, a method call is an expression, and so it must evaluate to a certain value. So, excuse me, what Java is going to do is it's going to call this GCD method, which has to return an integer, and it's going to take that expression that is returned, which is an integer, and it's going to set it equal to this integer c. So, when the call to GCD begins, the formal parameters are effectively declared. So every single time that you call a static method, you have to make boxes for your two integers, or let's say you have a string or a character that you're passing in. You make variables called formal parameters that are effectively declared. And this is a very important concept. These argument values are copied in to initialize them. So the arguments that you pass into a static method are copied into the values of the formal parameters. So anytime that we reference I or J within the static method GCD, we're referring to the parameters or the arguments that were passed into that GCD method as they are copied in. So let's say that GCD, we passed in, instead of 24 and 80, we pass in 2 and 4. I and J would be 2 and 4 respectively. And the order that you pass them in determines the order that they're copied in. So the argument values are copied into them. While this is happening, execution of the calling program is paused at the point of the call. So at the point where you call the GCD method, and the control is transferred to the beginning of the method body. So Java is saying, hey, this static method that we're calling, we need to call all of the code that's in that function. And then after all that code has been run and we have an expression, we can continue. But for now, put things on pause down here. So the scope of these variables is the calling program where they are declared. So you cannot use variables outside the scope of which they were declared. So if these are in a main method, then you cannot call out.println A, out.println B in this method because they're not in the scope. And vice versa, you cannot call out.println I or J outside of the scope of the public static int GCD method because they only exist when within the context of the GCD method. So the scope of these variables is the method body where they were declared, cannot be used outside the method body. So we initialize an integer k equal to 1. And then let's say that there's a bunch of other code that actually computes the greatest common divisor between 24 and 80. And who knows what that might be, but let's say that I gets updated to 0 and j gets updated to 8. So we're updating these formal parameters within the method body, and k somehow ends up being 8. Now, the big concept, and if you're not paying attention right now, or if I'm on 1.5 times speed because you're trying to get through this lecture quickly, I would slow it down because this is the big concept in parameter passing. Even though we have updated the values of I and J within the static method, the values of A and B remain unchanged because we copied the values. We did not pass the values by reference, which is something else we'll talk about. But this I and J, despite the fact that they started at the same values as A and B, are entirely different values at the end. And that has no effect on A and B in the main code. So the return statement immediately ends execution of the method body, and we're returning K back as the expression. So this evaluates essentially just to 8. And the return value is copied back to the calling program. The method body has finished, so its variables go away. So I and J are deleted by Java's garbage collector, it's called. And then the big thing is that the values of the formal parameters are not copied back to the arguments. So 24 and 80 were the values of the integers before the method call. After the method call, even though we've updated I and j within the static method, the values of a and b are unchanged. So execution of the calling program resumes in mid-statement, and the value that was returned by the call is assigned to C. So we have 24, 80, and C. And then the program will continue on. So when you call a method, how are the arguments connected to the formal parameters? The parameter values are copied into the formal parameters to initialize them. And when the method called method body returns, our results communicated back to the code that called the method. Only the return value is copied back to the caller. The formal parameters are simply lost. And I believe that there is a tracing table that we'll get into, but the name for this is called by copying or call by value. I'll say pass by value in this class because you're passing the values into the formal parameters of the static method. This is like a huge concept. So if you have integers a and b, and then you call a method that is somehow going to copy those values into formal parameters and then modify those formal parameters, after the method is concluded, the values of a and b will always be the same. There's no way to modify the arguments that you're passing in with what are known as primitive types, which are integers, chars, booleans, that kind of stuff. Okay, that is parameter passing, at least the simpler version, which is pass by value. Parameters are copied into static methods where you can do anything you want with them. After they return back to the main method, the parameters are the same. Cool. All right. So the second concept that we're going to talk about today is arrays, which are another huge fundamental concept in computer science. So what are arrays? Arrays are a group of similar variables, all of the same type, and with systematically related names that involve special syntax using brackets there. Each array element, e.g. a sub 0, a sub 1, acts like a single variable of the type used in the declaration of array A. So an array is a way to group similar things together when you want to have them stored. So let's say that I wanted to create a Carmen 2.0 and I wanted to have a class that was full of students. I could have an array of students because I would want to group them based on their similar characteristics. Instead of just having a variable for each student in my class, I could have an array of students that would store all of the students. So compared to mathematics, this is entirely parallel. We're talking about the way that you reference elements within an array to the use of subscripted variables in mathematics. So you pronounce x sub 0 as x sub 0. And usually when you're referring to array elements, you refer to them as a sub 0 in a Java program. You can also perform arithmetic with them. So x sub I plus 2 would be the same as a of I sub 2. And if you're wondering what we mean by the 0th element in an array or the I plus 2th element in an array, we will get to that in like the next few slides. So a group of related variables is called a vector x of length n. In Java, a group of variables a sub 0, a sub 1, all the way up to a sub n minus 1 is called an array a of length n. So how do you declare an array? Well, this bracket here is really what determines it. So consider declaring a normal integer in Java where you just have int a. Adding a bracket to the right of whatever type of variable that you want to make will turn that into an array of that type. So instead of saying, let's say this was string a, you could do string brackets a, which would be an array of strings, or bool bracket a, which would be an array of booleans. The brackets in this declaration indicates that there will be some number of variables named a sub 0, a sub 1, so on and so forth. How many? Well, that's where we get into the second part, which is this new int with a size variable. So how you would read this is that a is an integer array, which is a new integer array set equal to a size of 4. So we want a new integer array with 4 variables in it, or space to hold 4 variables in it. This is one way to initialize an array. There are other ways as well. You could just initialize it like this, where you're saying, hey, A is going to be an integer array. I don't know how many elements are going to be in it. I don't know what elements are going to be in it, but it's going to be an integer array. This many. Here, 4 is called the length of the array, and it is the value of another variable introduced by this declaration, a.length. So Java has this length built in to any time that you create an array that you can reference. So anytime that you create an array, you can call whatever the array's name is .length, and it will return the length of the array, which is the amount of elements that you can store within it. And this is the picture that you want to pay attention to. This is what results after the array has been created. So you have an array where you have space to store 4 integers, and a.length in this case is 4. Now, we call this indexing each value by providing it a way to reference it. So how do I get the first element in the array? How do I get the second element in the array, third element, and the fourth element of the array? Well, we use indexes. And an important thing to note is that we index starting at 0. So if you're wondering why we do that, it's a little bit to do with lower level programming languages and how they do arithmetic. But essentially, it's easier to just start it at 0. There are other programming languages that start it at 1, such as MATLAB. Most programming languages will index at 0. So if you're referring to the last element of an array that has 4 elements in it, it's actually the third index. So the third index. And these terms are interchangeable as well. So sometimes you might say, what is the 0 element of an array? 0th, the first element of array, second, third. Sometimes people will say the first element of array, even when they mean the 0th element. Sometimes it's a little bit confusing, but indexing starts at 0. So we have an integer array. How we actually, how we actually populate the array, there are a few different ways. You can say a sub 0, a sub 1, a sub 2, a sub 3 is not a way to do it. There are other ways that you use to populate the array. Java does this already for you, us as well. So anytime you create a new integer array, it will populate it with zeros and also populate the length. Here's another way to declare an array, which just provides it with the values. So if you say, hey, I want an integer array and I want it to have these values, Java will automatically populate that array for you with the length variable that we talked about. So a.length in this case will be automatically set to 4 because you're passing in 4 integers. Here again, we have a.length equals 4, but now the 4 array elements have different values. So a sub 0 is 6 in this case, a sub 1 is 18, etc., etc. And this is what that looks like in Java's memory. Okay. Going back to the other picture. This is illegal Java code, but is the net effect of the array declaration / initialization above. So you can imagine every single time that you're creating an array this way, Java is doing this, where it's saying, hey, the first element or the 0th element should be 6. The first element should be 18. Second should be 9. And then the third should be -4. And its length should be equal to 4. Okay. Array indexing. So this is what I was talking about a little bit before. You may write an int constant, literal, c between the brackets, as in a sub c. So c in this case is an int constant, so long as the value satisfies that it is between 0 and less than a.length. So if you have an integer array that has 4 elements in it, how you would refer to the last element in the array is a sub 3. And here it looks like that we're setting a sub 3 equal to 17. If you try to reference a sub 4 or a bracket 4, you'll get what's known as an array out of bounds exception because there are not 5 elements in the array, there are only 4. We started indexing at 0, so 4 in this case would be out of bounds. So after this code is executed, we have that a sub 3 is equal to 17. So let's say that we have an integer array that has 4 elements in it. How would we refer to the last element is we would say a sub a.length minus 1 equals 17. This is the same exact piece of code as this. And this is useful if you don't know how many elements are in the array, or if it's a large number, like 2,432, you don't want to write that. So you can essentially just say that the last element of the array, or a.length minus 1, is equal to 17. After that code is executed, we have a sub 3 equals 17. And that's arrays. You'll get a lot of practice with them throughout the course and in the labs and stuff like that. If you have any questions, please DM me on Slack. Let's see here. I'm trying to think of a good attendance question. Today's attendance question will be, what is your favorite season? Are you a spring, a summer, a winter, or a fall type person? So I will include the attendance link in the video lecture that I upload, but that question will be the question that you have to answer in order to get attendance points for today. All right. Have a good day.